Hi, this is MC Shetty for a new episode of my modding tutorial, and I'm going to implement a mana system in this tutorial. So in the top left corner you can see two numbers. The second one is how much mana is in a chunk, so that's something that we will generate and keep in the chunk, and the left number is how much mana the player has collected. And I made it so keybinds that there's a key binding, tutorial keys, gather mana, and it's set to dot by default. So if I press that, you can see that the mana for the chunk decreases until it's empty, and we have to go to another chunk to collect more mana. So that's basically what we will implement this tutorial. In the next tutorial, we will actually make items and stuff that uses mana. So yeah, let's get on to it. So to make this mana system, we will use data that is attached to the world, where we store the mana available in the world per chunk. And we will also need data that is stored with the player, like how much mana is the player already gathered. So we start by making a new package, mana system, and in that package we will set up 3 different sub packages: client, data, and network. So first, let's start with client. And on the client system, on the client side, we actually want to have key input. So when we press our dot key, we want something to happen. So let's copy 2 things here. I will explain them. So key bindings is where you define how the keys, which keys your mod supports. So we make a gather key mapping, a gather mana key mapping, which is new key mapping with this key, which is used for the language file. You specify where the key will be used in game. So there are some other possibilities here: universal, only in GUI, or in game. We want in game. We want this as the default key, and this is the category, which is also a language key that is translated. And then we say register this key binding. We have to call this from somewhere, and we will call that in here. Oh, not here. Key bindings init. Because if you go check this, you can see that it's synchronized. So that means we don't have to use this, put this in here. We can put it safely in here. It's thread safe. Okay, so this defines the keys, but now we need to be able to listen to when that key happens. For that, we have an input handler. So basically what we do here, whenever a key input event occurs, so when the player presses a key, that's an event that occurs client side. You go check it out. This event fires when a keyboard input is detected. We check if our key mapping is consumed, and if so, we will send a packet to the server, because mana gathering has to be done on the server. So we have to define this, but let's first register this one. That's also in client setup. And for that, we add a listener. Okay, so we add a listener for this event on the client. So we are in client setup and we add this to the Forge bus. So 2 steps for key bindings. First, define the key binding itself, then make an input handler for it. We will also fix the language provider and add two languages like this. So that's the default English translation for these keys. That's why it looked nice in the game. Okay, so now we need networking. We need to send a message to the server that we clicked, that the player clicked the gather mana key mapping, or the gather mana key. So first in setup, we make our messages class, which is the main class for networking. Okay. And yeah, let's do some things here. So basically, we make use of simple channel, which is something that Forge added. It's an easy way to make a network channel between the server and the client for your mod. So we make a new channel. There's a channel builder. We give it this name, a network protocol, and we actually don't use. Here you could check if the server side of your mod is compatible with the client side. Using this, you can, for example, make sure that you have a mod that works with older versions on the server as well, but the client can be updated, or you can make sure that it has to be exactly the same version. That's up to you how you use it. I generally leave it as this, because typically mods are the same version anyway. Okay, so we have to call this register somewhere, and that's done in mod setup. Right here. Say again, I believe this is from Forge, and all Forge things are automatically synchronized, but you can't actually see that here. Yeah, it uses logs, but things for Forge are typically okay to use like this. Okay, so this initializes our channel that we can use to send messages from the client to the server and the other way around. Now we need to define our actual packet. And we will put that here in network. Let's copy it and explain what it does. Yeah, we don't have a mana manager yet, so let's put that in comments for now. Okay, so this is a simple message. It has no data. We just want to tell the server that the user pressed the key, so it doesn't contain any data. That's why this is empty and this is empty. In this tutorial, we also get a message where we do have data. Then I will explain this more. The reason it's still here, it's because it makes it slightly easier to register. And yeah, that's why I do that like this. Then we have handle. This is actually called when the packet is received on the server. So it gets a supplier of a network context. You get the actual network context, and then this is important. As soon as you receive the message, you use enqueue-work to ensure that you are on the correct thread, because otherwise here you are in the networking thread and it's not allowed to do, for example, things like getting a block entity or accessing the world here. you should do that in here. That's why there's always this, and it will make sure that this code is executed in the correct thread. And then you return true to say to the system that the message was handled correctly. We also need to register this. And that's done like this. Okay, so to our simple channel, we create a message builder. This is the class of our message. This is an ID, which is just a number that keeps increasing. And we say it's from client to server. It's a message that goes to server. This is the decoder, which is just this constructor. It doesn't have to do anything really. This converts, that's the encoder, it converts the packet to bytes, and again, it doesn't do anything for this particular example. And this is the thing that will handle the message. We also added a convenience function. This is just so that we can keep this private. We have a send to server here with a message. Note that messages don't implement or extend anything. Every class can be a message, and that's why it's done like this using generics. Okay. All right, so this is basically it. Oh yeah, we also need, we'll do that in a moment, but our message doesn't do anything yet because we don't have the manage system ready. I will do that in a moment. So basically, let's put this back. What do we want to do? Whenever the player presses this key, client side, we send a message to the server. And on the server, what do we want to do there? We want to get the mana that is present in the chunk, which we will do that in a mana manager. We extract mana at the position that the player is. If there's no mana to be extracted, we send the message to the player, which will come as an error message, translatable component, message no mana with style in red, and this is to indicate that to the current player. Is there a comment with it? No, there's no comment with it. Okay. If there's mana, if extracted is greater, then we will add the mana to the player using capabilities. So here you see this uses world data, this uses player data, and we will expand on this in this tutorial. First, let's add some language keys for this, like this. Okay. So mana manager will store the mana in the world. So let's make a class called mana manager. And to store something in the world, what I like best is to use this. Extend save data from Minecraft. This is something that you can use to attach data to a dimension, to a world. Okay. Let's copy some code. So we need a constructor and we need another constructor. Yeah, that doesn't work. Okay. What's the problem here? Yeah, we just need. Okay, so basically we extend save data and we make a public static method to get that data from the current level. This only works server side, so for that reason we added a protection here, so that if we ever try to do this client side, we will get an error. Otherwise, we cast the level to server level. We know we are server side, and we get the data storage for this dimension. And then we do compute if absent, and the first is parameter is a function that converts a compound tag to mana manager. So that will be this constructor. So basically we read from this is used if the mana system is already saved in this dimension. If it doesn't exist yet, then we use the supplier mana manager, which will be this constructor. So yeah, if you know generics, you know this, but this is not the same as this, because this corresponds to this constructor and this corresponds to this constructor. So that's important to note. And then you give it a name. So this line makes sure that if the mana system is not present, then this constructor will get called and it will be added to the data storage. If it is present, then this constructor will be called and it will be loaded from the level data. Okay. So yeah, and we want this data to be per dimension. Okay, so that's because if you want really global data, global that is over the entire server, then you can access your data on the overworld, because the overworld is always there. You can always add data to that. That's for really global data. But in our case, we want this to be per dimension. So what do we want to store per dimension? We want to store how much mana is still left in every chunk. So let's first make a very simple class, which is the mana class. It's just a class that contains one integer, a constructor, a getter, and a setter. Nothing more. That's very easy. And then we make a map which maps chunks positions. So that's a class from vanilla, which has a chunk coordinate to mana. So for every chunk we store mana. It's initially empty though. We also need to load and to save this. So let's get some code for that. First, to save, we use this. So basically, we need to save the mana for every chunk. So we need to make a list. So we start with list and we add that list to the main tag. And then for each, this will be, let's give it a better name, chunk boss. And this is called mana. So for every mana instance that we have in our map, we make a new compound tag. We store the X value, the Z value, and the mana value, and we add that to the list. So this is how we save our data. To load it, we have this code. So we get the list from the tag with this name. The elements of this list are of that type, so they're compounds. We iterate over the list we cast. We create our mana instance. We create our chunk boss, and we put that on the mana map. So this basically solves loading and saving. Okay. Let's add a simple helper. Get mana internal. Also, we need a random. Hold on, I will explain this. So basically, oh yeah, and we have configuration. This function, which we will use in a moment, will get the mana instance at a given position. So first we convert the position to a chunk position. And then we do again compute if absent. So we try to see if we already have mana at this given position. If so, we will return that. Otherwise, we will make a new mana instance with random mana in it. Okay, so let's add the mana configuration as well. Mana config here. It's a server-side config, and we have a chunk minimum mana, chunk maximum mana. And let's add that so we have new configs for our mana system. Okay. So this is how we populate our chunks in a lazy way. We don't pre-generate this, but every time a position for a new chunk will try to get the mana, we will generate a new mana for that chunk randomly. Okay. We need a way to get the mana at a certain position, a public way. So public int get mana. We call get mana internal, and we return the mana at that position. We know we can do this safely because this will always return something. It's not null. And we need a way to extract mana. Okay. Given a position, we get the mana internal. We see how much mana is present. If it's greater than 0, we decrease it. This is important. We mark it set 30. If you don't do this, then our save will not get called when the world is saved. So you have to, whenever you make a change that needs to be saved here, you must call set 30. And then you call null. So normally, extract mana works here now. So basically this line, first we get the mana manager for this level. We extract mana from it, and this will automatically modify the mana in the level. And then we will add it to the player. So let's do that now. First, let's add a player mana class. Oh, I wanted to add it. I accidentally pressed cancel. So again, this is like a bit like the mana class. It also holds the mana int. It has a getter, a setter. It also has an add mana. It's a bit easier. And then I will explain this later, but it also has a way to save and load itself. Save NBT data, load NBT data, and it just stores the int for the mana. That's very easy. So this data is what we will store with the player. How do you do that? That is the easiest way to do that is using capabilities. And for that, we have a player mana provider. And this will require some explanation. So this is a capability provider, and it's also serializable. So basically, this means this is a class that, you go check here, it implements get capability so that we can get our capability, and it implements serialize and deserialize. Here we define our actual capability. So we have a capability of capability player mana. So that means that this is the data that we want to store with the player. We give it a name. And then this line doesn't really matter, but this is what you have to do to actually initialize this. In our player mana provider, we have a player mana and a lazy optional for get capability. So remember in our block entity tutorial there we also used capabilities for forge energy and for items, and you use lazy optionals to store the mana, to store the capability. And this is the supplier, create player mana, which will use the cached player mana that belongs with this provider. Player mana is new player mana, and this will then be stored in the optional. we implement get capability, and the cited version is exactly the same. And then serialize and deserialize, we to create player mana, and we do the save NBT or the load NBT data. Okay. Now, to make this actually work, there's a bit more magic that we need. Let's copy a class and then explain what happens here. In this class, we have various events that can occur where we need to manipulate the capability for the player. So first, there's attach capabilities event. This event allows you to attach capabilities to something. In our case, we want to attach capability to a player. So and a player is an entity, so that's why we use this. But you can also use this to attach capabilities to block entities or to other things, to chunks, for example. For example, for block entity, you would typically only do this when you want to attach a capability to a block entity that you don't own yourself. So, and also you don't own the player. The player is something from vanilla. So that's why you need this event. So if our object is instance of player, we check if the player mana is already present. And if not, we do add capability. Let's actually call this player mana. And we attach our player provider to it. So that's how you add a capability to the system. But there are also other important things. Attach a player capability to the player, I mean. When the player is cloned, so this occurs caused by death or by traveling from the end to the overworld. For some weird reason, when you travel from the end to the overworld, the player actually dies, and then you lose all capabilities, just like that the player loses all items. And to fix that, you need, if the event was death, you need to copy the player mana from the old, from the original player to the new player. And that's why we need to copy from. So that we can copy the mana so that the mana is not lost. If you want, you could implement a system here where mana, for example, you lose 10% of the mana if you die. You could do that here. That's something that that's up to you. We also need to register. So here we attach the capability to the player, but we also need to register our capability. So we basically need to register player mana as a class that is our capability that we want to support. Okay. Yeah, and this I will explain in a moment. That's for later. So these we need to subscribe to these. Let's do that first. Also this. Yeah, okay, we need to do some imports. Okay, so this will now work. Let's explain that first. We get the mana capability from player, and if that's present, we add the mana that we extracted from the player. This should normally always be the case because we make sure that the player has the capability. All right. So basically, to register our 3 new functions, we need to do this. So add listener on player cloned, that's for this one. Add listener on register capabilities. This one is special because it's an event that has generics. You actually need to use add generic listener with the class for which this is meant to be used. Okay. Okay, so remember, remember that we showed our mana in the top left corner. To do that, we need our mana back on the client. So we started from the client when the player presses the dot key. But the rest of this processing, all this is server side. So the client doesn't know what the mana is in a chunk, and the client doesn't know what the mana is on the player. So we need to communicate that to the player. And we do that on a regular basis. So that's why this is important. So let's first, let's explain this. Worlds have levels or worlds have a tick. Every tick, every world will get a tick. We don't want to tick client side, and we only want to tick at one of the two phases. So there's a start and an end phase. Otherwise, we would tick twice every 20 times per second. Then we get the mana measure for that world, and we call tick on that, which is not implemented yet. So let's do that. I actually want to put it in here. So what do we want to do here? Here we want to make sure that every time that the data is synced to every player in this level, so that that player can show it in the HUD. All right, so how do we do that? Let's copy some code. And we need a few variables. We don't want to send this to every client every tick, so we do this twice per second. That's fast enough. There is here a possible expansion, keep the previous data. So I'm not going to do that, but you can in principle keep the previous data that was sent to the player and only send if changed. That would be an optimization. And another expansion here is to slowly regenerate mana in chunks, but I will also not do that. That's things that easy to do by yourself. But basically what we want to do for every level, every 2 times per second, we check all players. For each player, we check if it's a server player. That will always be the case. We get the player mana, and we get the player mana from it, and we get the chunk mana. So chunk mana will use this, and player mana will use the capability system. And we want to send that to the player using a new package, which will go the other way. So this is a packet that goes from server to client. Yeah, we need to fix that. This is a packet that does have data because we want to send these two integers to the client. So that's a constructor. This is the constructor that reads these two values from our byte buffer. And this is the method that will serialize it to the byte buffer. Okay, let's first register that. Okay, so basically we have a new message. It goes to the client this time, and that's how we do this. We also need a new convenience function to send to player. So here we use instance.send packet distributor player with the given player. That's how you can send to one player. There also you can send to all players, but we don't want to do that because every player can be in a different chunk and has different mana. So we need to target every player individually. Okay, so that should fix this. Okay, so this works now. But we need to store our player data client side like this. This is a simple class that holds the mana that was received from the server. It's static because, client side, you are alone. There's only one player, that's you, client side, so you can keep that in a static variable. That's okay. So one important note here: this is a packet that goes from server to client. So this class has to be available server side as well as client side. But that means that you cannot use things here. For example, it would be illegal to do things like this here. You can't do that here because this is a client-side class. You can see that because it's annotated with this. By the way, never use this for yourself. It's not needed. This is purely meant for Minecraft and for Forge. It's an ugly hack. You shouldn't use it. But you can, if this is present on a class, you know that it's only available client-side. So it's not safe to use that here because that would mean that this entire class can't be class loaded on a server. So to do that, it's always a good idea to put actual client code in a different class. So that's why we do that here. All right, so basically we're almost there. So we have our two packets. So we have the thing to send from client to server. We have our mana manager, which sends data back from server to client. And the final thing that we need to do is actually implement the overlay. So let's do that. So there's a very nice new system in Forge, which is in-game overlay. Basically, you define an overlay, which is just a simple interface that you implement that has these parameters. And in that, you can do your GUI stuff. In this case, we get from client mana data, the player mana, the chunk mana, and we draw it on screen on this location. Ideally, you would make this configurable, and we will do that in a moment. But basically, that's how you can do this. You need to register this overlay, and to do that, we go to the client setup, because this is client side, and we add this. So overlay registry, so we do that in init, register overlay above, hotbar element. So we want to register above the hot. That's not the position above the hotbar, but in what order it will be rendered. Yeah, we give it a name. I'm not sure for what that's used. It's not actually showing. And then our game overlay. So that's very easy, a very easy way to make a HUD. Let's add some config for it as well, so that you can configure the position where this is stored. Mana HUD X. Three values and register client configs. Okay, and then mana HUD X location of the mana HUD. Default is 10. Yeah, okay, that's fine. Actually, you could set the min value of -1, and then you can say if it's -1, you disable the HUD. Let's do that. That's even friendlier. Default value. All values are allowed here. So this is basically white. Everything set at maximum. We need to call this like this. Okay, and then we actually need to use this. And also we need to test. Let's do so if x and like this. Okay, let's try it out, see what happens now. Okay, yeah, there was already an error. I think IntelliJ is a bit confused. Let's start it again. Okay, this is better. Yeah, for some reason it was a bit confused. Okay. All right. So apparently, for some reason, okay. So the HUD is showing. Let's see what's wrong. Let's do some debugging. Oh yeah, I forgot to generate the thing. That's why this is not working. But there are some other things not working. So let's try to find out. Also, let's go to creative. Let's find out what's wrong. So let's do some debugging. That's actually pretty useful. So I probably forgot something. So let's first start with the key binding. Input ender. Let's set a breakpoint here and see if we get to that point. We do. Okay. So that means that this is at least done. Let's get here and set a breakpoint here. Okay, he also gets here. So I pressed continue, extracted. We extracted 1, so that's okay. And actually, so we did get some mana from the level. So that means, did we forget to do something? Let me check. Mana events. Is this actually called? No, that's not called. So that's our problem. And I know why. I forgot to add the listener for that. Okay, let's go back. So using breakpoints is an easy way to find out if something is wrong or not, or where the problem is. All right, let's see if it works better now. Yeah, but it's in the way. You can't see it. I could, of course, move the top interface, but let's try and see if we can. I don't know if this will work at runtime. Yeah, it works at runtime. So let's go to chunk that has almost no mana. So not this. Oh, this is low. Okay. Let's check that our message works correctly. Yeah, okay. We need to fix the translations. So for that, we call run data. Okay, so normally, yeah, these two and this one is now correct. So that basically concludes this tutorial. In the next tutorial, we will add some items and some rendering to make this more fancy. But this is the basic mana system. So see you next time. Bye bye.